Hello and welcome to York University Astronomy and Astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I am undergraduate Paul Mackin, one of your hosts this evening, and I am joined by my friends Suna Withers, who is a PhD candidate, and Maheen Hamani, a research assistant, and we're each affiliated with the Department of Physics and Astronomy here at York University. Tonight, we are broadcasting live from the Allan Carswell Observatory on the Keele campus in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal Time at York U Observatory. We also run in concert with our online public viewing, or as we call it, the OPV, which is a feed run by the observatory staff where, it being winter and all, we are not observing due to inclement weather. The crew will instead be showing beautiful archival images and answering your questions on YouTube chat. To navigate to our live show or to find out more about us, please check out our website at yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. Any questions or comments you may have on past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can also always connect with us on Instagram with the handle at York U Observatory or on Facebook at Allan I Cars Web Ob. All of our programs are free, but if you'd like to make a donation, and we would certainly appreciate that, please see our website at yorku.ca/science/observatory. We will be monitoring the YouTube chat for questions and post content. So, where I am, it's kind of cloudy. What about you, Suna and Maheen? Are you also stuck in the winter observing doldrums?
Oh, definitely. I am really missing observing, but it just hasn't been clear enough to observe. Annoyingly, the forecast tonight was supposed to be very, very terrible, and we are getting high winds, so we can't open the dome, but it is decently clear outside. So if anybody's wanting to just do some, quick stargazing or are willing to put up with freezing cold wind.
Yeah, I was thinking about taking out my little sea star, which is a very small telescope, and putting it in the backyard. It's a smart scope, so you basically tell it what you want to look at, and it takes a bunch of pictures for you. Um, but even at that, it's not that great in high winds because
Mhm.
it's kind of square, so the winds can very easily blow it over. So I don't think we'll be doing that tonight. What about you, Maheen? Where are you located?
I'm currently joining in from North York. I was actually quite hopeful for clear skies tonight, but because it was very clear in the afternoon and the evening when I went for a walk outside, I saw the sunset, but unfortunately, it just started clouding out as soon as we started preparing for our broadcast. So it's not looking very good for the skies tonight.
Yeah, I know. An astronomer's interest is much dimmed in the winter, I'm afraid,
Mhm.
in North America. Although we still do get some great observing opportunities, and I have to say the winter skies, when weather cooperates, they take some beating. They really do, and we should probably in a future podcast start to introduce the sky at night again, and I think we'll get to that probably starting at the beginning of February. But in the meantime, it's time to talk about this week in space and astronomy history. So, Suna, you've got an event that I think is really quite fantastic. And why don't you tell us about Gemini?
Yeah, so the actual date was yesterday in 2002, January 18th, which was the dedication of the Gemini South Observatory. So Gemini South is a twin telescope with Gemini North. These are two essentially identical telescopes both 8.1 meter diameter telescopes that observe optical and near infrared light. There's one of them that's located in Hawaii up on the top of Mauna Kea, which is Gemini North. And then Gemini South, which we're specifically talking about today, is actually located at the summit of Cerro Pachon in Chile, which is at an altitude of around 2,700 meters. So the idea between having these two twin identical telescopes is that if you have one in the northern hemisphere and then one in the southern hemisphere, you essentially get high quality, good coverage of the entire night sky. And while this is something that you can do, I guess, relatively easily with space telescopes, as long as you put them in the right orbits, it's really not something you can do effectively with ground-based telescopes. Because if you're in the northern hemisphere, you can only see the northern part of the night sky. If you're in the southern hemisphere, you can only see the southern hemisphere of the night sky. So there's always locations of the sky that's kind of inaccessible to you just based off of where your telescope is located. So the idea between the Gemini North and South observatories is you build two identical telescopes, put them on opposite ends of the globe, and then from there, you have coverage of the entire night sky. So anybody in the member states and in the countries that were providing funding to Gemini could access the entire night sky with 8-meter class telescopes and great instruments. And speaking of member states, the Gemini telescopes are primarily funded by the United States through the NSF, but they do have partnerships with a lot of other places, including Chile, where the telescope, the Gemini South is based, and also Canada. So there is also a pretty strong contribution from Canadian astronomers to the Gemini telescopes, and it really makes it kind of a broad international collaboration, which is always an amazing thing to see in astronomy. So Gemini North opened first in 1999, and then Gemini South opened around 2001, 2002, with the dedication specifically taking place on January 18th, 2002, up at the summit. I believe there were around 50 or so people from various member states who came out to see the dedication of the observatory, which I don't remember specifically what it was dedicated to, but there was definitely a lot of kind of celebration of contributions of thousands of different people across the globe, which included astronomers working on science and also engineers who were working on building and actually planning out both telescopes. Another interesting thing about the Gemini North and South observatories is that, especially at the time they opened in 1999, 2001, they were using a lot of really new and very groundbreaking types of instrumentation. This included a system called adaptive optics systems. So if you ever see pictures of telescopes shooting lasers out into the sky, this is a type of adaptive optics where you can essentially just observe the conditions of the atmosphere. You can see what effect that has on stars, and you can remove that contribution from your images. So the most obvious way or kind of intuitive way that most people will see this sort of effect is if you go out on a night, particularly a night like tonight that is very windy but clear, you might actually see a lot of twinkling in the stars out in the sky. And that twinkling isn't from the stars themselves intrinsically twinkling. It's just because when their light passes through the Earth's atmosphere, when there's a lot of high winds and the atmosphere is turbulent, it kind of shakes the light from that star in kind of a messy way, which results in seeing the stars kind of twinkling in the sky and not being this sort of static point source up in the night sky. And this is something we notice with our eyes. So you definitely notice it when you're using sensitive equipment like 8-meter telescopes of Gemini North and South. And with those telescopes, the effect is really, really bad. It can turn even, these great high resolution images that you can get with these massive telescopes into kind of blurry messes. So it really limits the amount of science that you're able to do, which is the exact thing that adaptive optics is designed to correct for. You just kind of in real time observe the way the atmosphere is moving and affecting light from stars, and then you can correct for that with the optics and kind of remove that blurring effect that the atmosphere has. So it's really opened up a lot of the science that Gemini North and South were able to do as opposed to if they didn't have the adaptive optics systems. And its research interests or research focuses really range across a whole whack of astronomy. So it can do everything from looking at the formation of stars and planetary systems to looking at the formation, or not the formation, but looking at the dynamics of supermassive black holes that exist in the centers of galaxies. So it's done a whole bunch of really amazing things during its lifetime. Now, today, even in 2025, both the Gemini North and South observatories are still operational. And have been doing a lot of interesting, groundbreaking research even today. So I was looking at the list of sort of research publications that came out recently from the Gemini North and South observatories, and it included some stuff on Comet 3I Atlas, which was a very popular observing target for both professional and amateur astronomers over the past year. So lots of really interesting observations of that, including coming from the Gemini observatories. And it also recently helped discover that the star Betelgeuse has a companion. So Betelgeuse is a very bright star in the constellation Orion. So you can observe it now since we're still in the winter months. It's the left shoulder in the constellation Orion, a bright red star, which should be going supernova any time soon. Don't know an exact date, but kind of any time within the next 100 years, this star might blow up. It will be so insanely bright when it does that you can actually see it during the day. So Betelgeuse is a very popular and interesting target to astronomers. And astronomers had been long predicting that Betelgeuse had this very small, very faint companion star to it, but it hadn't actually been detected yet until the Gemini observatories were able to observe that target and confirm that it does have a little companion star there. So lots of great stuff coming out of the Gemini observatories. They have been doing this for over 20 years. So it's a great anniversary for astronomy.
Yeah, it's really quite an impressive system. And I'm so glad you mentioned Canada's involvement because, we really do. We're not the biggest country. I mean, we're 40 million people, and the USA is 10 times our size. Europe's way larger than that even. But we punch above our weight, and that's quite gratifying. And we're particularly good. Our space agency is pretty small, but our astronomy work is both world class, and we take it very seriously, and we invest in it. So it's great to hear about our involvement there. And I'm also fascinated by the adaptive optics. Adaptive optics were first developed at the Lick Observatory in San Jose, or near San Jose in California. And I was very fortunate years ago to get a private tour of that facility, and I sort of conned my way into it. But just incredible technology, and it's really changed how we do Earth-based observing.
Yeah, especially for like the next generation of telescopes, the 30-meter class telescopes. One of the big selling points for those is just sensitivity and resolution, where it will beat out the James Webb Space Telescope for being able to get these crazy high resolution images of the night sky. But of course, you can't do any of that if you don't have the adaptive optics. Even for telescopes like massive 30-meter diameter mirrors, you really, really rely on these adaptive optic systems. But
Yeah,
yeah,
and
they're one of my favorite things to learn about in astronomy. I remember the first time I heard about adaptive optics and the fact that you can actually in real time make these measurements and deform a mirror and like change the shape of a mirror to like account for these itty bitty like minute differences coming from the Earth's atmosphere. It's really crazy. It's a very, very cool thing to be able to do.
Yeah, it's the changes in the techniques and technology behind data gathering and imaging now. Between that and the rather than long film-based exposures, now we're doing digital stacking and we can do incredible data analysis on those images. It's really quite incredible, and we're doing most of that from Earth because space telescopes are hard and but we also go places, and I think Maheen's got a story she wants to tell us about that.
Yes. Before I go into that though, I just want to say I've really been waiting for Beetlejuice to go supernova. I wish there was a way we could speed up the process. Like I'm really waiting for that to happen soon.
Me
Um,
too.
yeah, and also on Sana, your story, I just wanted to say like it's so great that, with globalization, how like two hemispheres come together and then we can observe things we can not otherwise see. So the northern and the southern hemisphere collaborating with each other. I find that really amazing. Um, Same with adaptive optics, where we're still limited by our environment. And so that kind of reminds me of the benefits of globalization and technology and, um, where people don't like all of those things. There's also these benefits in astronomy and from an astronomical perspective. So that was a very interesting story to hear.
Yeah, absolutely. That is one of the great things about astronomy too, is it really encourages like these international collaborations. So
Mm-hmm.
you still see, I to an extent we'll talk about this a little bit later on, but to an extent you still kind of see a lot of collaborations, even kind of regardless of the political environments, there's still a lot of uh, collaboration happening within astronomy.
Yeah, all right. So I will now take us to the next This Week in Space and Astronomy. So I'm going to be taking you back to January 24th, 2004, which was one of NASA's most successful interplanetary missions, the Opportunity rover's landing on Mars. So this launch was part of NASA's Mars rover exploration mission, which is under the bigger program called the NASA's Mars Exploration Program. As part of this mission, the Opportunity rover was launched on July 7th, 2003 from Cape Canaveral in Florida and took 6 months to travel to Mars, ending up landing in early 2004. It landed in the Meridiani Planum, which is a flat plain near the equator of Mars, 20 days after its twin rover called Spirit, which landed in the Gusev crater. Both are regions on the red planet suspected of having been affected by liquid water in the past. So, this aligned well with the mission's main scientific objective, which was to search for a range of rock and soil types and look for clues for past water activity. Fortunately, these objectives were achieved and several key discoveries were made, including finding evidence of Mars having potentially sustained microbial life in the past, which is one of the hot topics when we talk about interplanetary missions and other planets. Although we do wish that aliens were more than just microbial life, but that is something we will know in the future. The goal was to have rovers move from place to place, taking photographs and performing on-site geological investigations. The cameras were mast mounted on the rover, which provided a 360-degree view of the terrain, and it blessed our eyes with beautiful images of the Martian surface, which we have until today. Um, the discoveries that were made from this mission was for almost 15 years, which exceeded its life expectancy by 60 times, which I find mind-blowing. Unfortunately, after serving humanity for 15 years, it lost communication with Earth in June of 2018 due to a severe Mars-wide dust storm which had blanketed the region. And so we lost contact with the Opportunity rover. So, according to NASA, this was the first human enterprise having exceeded a marathon distance of travel on another planet. It was also the steepest slope a rover has ever driven on Mars. So, all in all, it was a very successful mission of one of the most explored planets in the solar system so far.
Yeah, it's the Spirit and Opportunity is a great story. When Spirit landed, I remember I was at Disneyland with my kids, and my wife at the time was very annoyed with me because I kept checking on my phone for news updates on whether the lander had made it down, the rover had made it down or not. I was supposed to be on a roller coaster or something with my boys, but also the way it landed was really cool, because it was kind of a hex, like a hexahedron, I guess, and surrounded by, as it came down with a parachute. So it basically, first of all, hit the atmosphere and slowed down with a heat shield, and then it fired off a parachute and ejected the heat shield, which slowed it down further. And then, as it was getting closer to the surface, it basically got rid of the parachute, fired some rockets, which slowed it down, and then they released this rover just to crash on the surface. And just before it crashed, it inflated airbags and then bounced. And there's some great animations because they captured the data using gyroscopes and whatnot of how many times it bounced and the direction it was going when it bounced. And so you can get these great animations of what it looked like. It's quite funny to watch, actually, but an amazing mission. And I always say NASA well, the Europeans do this too, but they over engineer their spacecraft. So I'm impressed at the 15 years, uh, but I'm not totally surprised by the 15 years.
Yeah,
Yeah,
and
I
it's so cool to hear that you actually saw this live because I think I was only 2 years old at the time. I don't know, Sana, how old you were, but it's so cool to hear that you actually saw that live.
Well, being an undergraduate who is closer to 70 than he is to 60, I am often reminded of the fact that I've seen things that a lot of my classmates have not. So, um, but speaking of someone who's older, tomorrow, January 20th of 2026, will be the 95th birthday of one of the few remaining people on Earth that have walked on the moon. All in all, 12 men walked on the moon between mid 1969 and late 1972. And of those 12, only four remain. They're getting old, right? So Jack Smith from Apollo 17, Charlie Duke from Apollo 16, Dave Scott from Apollo 15, and birthday boy Buzz Aldrin from Apollo 11. So yes, the inspiration for Buzz Lightyear will be turning 95 tomorrow. So he was born Edwin Aldrin Jr., and he is the oldest of the remaining moonwalkers. There was one older than him, that Jim Lowell, who passed away last year. He was born in 1930 in Glenridge, New Jersey, and he's of American and Swedish parents. He developed the nickname Buzz as a result of his younger sister, Faye, who mispronounced brother as buzzer. And ultimately, in 1988, he changed his legal name to Buzz. He was an excellent student and an athlete, and he earned a degree in mechanical engineering from West Point Military College. He flew 66 combat missions in the Korean War, and I think shot down a number of MiGs, I believe two. And then he went to MIT and earned a PhD in astronautics, which I think we would now call space science, from MIT. His doctoral thesis, Line of Sight Guidance Techniques for Manned Orbital Rendezvous, earned him the nickname Dr. Rendezvous from his fellow scientists. But his science background really would serve him well in a number of areas. He was selected as an astronaut by NASA in Group 3. So this was the third group of astronauts selected, the Mercury 7 being the first, and flew on his first space flight on Gemini 12. When you talk about things that you've seen, I would have been 7 years old when Gemini 12 flew, and I actually remember watching it. I have a distinct memory. It was the last Gemini mission, and I was watching it on TV with my grandfather. But during that mission, he performed 3 EVAs. So 3 times he went outside and did a spacewalk and spent over 5 hours outside the spacecraft during that flight. But spacewalks to that point had been really problematic. The astronauts didn't know how to grab onto things. They didn't know how to move. They had a tendency to overheat and overexert themselves. And so Aldrin, with his scientific background, was instrumental in developing a neutral buoyancy simulator and training for for spacewalkers. And that technique is still used today. So basically, the idea is you build a simulation of the spacecraft inside a swimming pool, and you put the astronauts into their spacesuits in the swimming pool at the depth necessary so their buoyancy is neutralized. They don't go up or down. So they're it feels like being in zero G, and they can practice the techniques necessary. And so he developed that, practiced in it, and then was probably had the most successful 3 spacewalks during the entire Gemini missions because they were really problematic. A couple of times they thought they might have to lose an astronaut because they were doing this for the first time. So in July 1969, he served as the lunar module pilot on Apollo 11 and became the second human to walk on the moon. He came down off the lunar module 19 minutes after Neil Armstrong, and he described the moon's surface as magnificent desolation. Now, interestingly, if ever you see a picture from Apollo 11 of an astronaut, it's likely going to be Buzz Aldrin, because Neil Armstrong had the camera on his spacesuit. And they've gone through the archives and they found exactly one picture of Neil Armstrong on the surface of the moon. There's lots of video, but there's only one photograph of Neil Armstrong on the moon. So after spending 2 hours, 31 minutes, and 40 seconds on the moon, Aldrin returned to the lunar lander, Eagle, and shortly thereafter, Armstrong came back on board, and then they had a night's sleep. How they would have slept, I don't know, and it didn't look very comfortable. They didn't, the LEM was extremely small, so I think they sort of propped themselves up and catnapped, and then they returned to Earth. Now, Aldrin never flew in space again. And he unfortunately didn't react to fame all that well and developed a bit of a drinking problem. But he quit drinking in 1978 and became an author and an advocate for the manned space program, something that he continues even to this day in '95. There are lots of stories about Aldrin. He is a bit of a character. And one story that's sort of a favorite of mine. On September 9th, 2002, Aldrin was lured to a Beverly Hills hotel on the pretext of being interviewed for a Japanese children's television show on the subject of space. And that was exactly the sort of thing he would do, gladly. When he arrived, moon conspiracy theorists, so just moon conspiracy theorists are people who don't believe we walked on the moon, a guy named Bart Sebrell, accosted him with a film crew and demanded that he swear on a Bible that the moon landings were not fake. After a brief confrontation, during which Sebrell followed Armstrong despite being told to leave him alone, calling him a coward, a liar, and a thief, the 72-year-old Armstrong punched the much taller 42-year-old Sebrell in the jaw, and the act was caught on camera by Sebrell's film crew. Aldrin said he acted in self-defense to protect him and his stepdaughter, who was with him at the time. Witnesses say Sibrel had aggressively poked Aldrin with the Bible, and there were additional mitigating factors that Sibrel sustained no visible injury and didn't seek medical attention, and that Aldrin had no criminal record. So the police declined to press charges, and the deputy district attorney of Beverly Hills office declared that Sibrel had provoked him. Now, I would never condone violence, but this story really does make me smile, because you've got this, person who's a little shorter than me, probably about 175 centimeters, and someone who's like 195 centimeters, 172, 142, and the fight doesn't go in the direction you might expect. But it's a great story, and it's a very typical Buzz Aldrin story.
Yeah, I remember seeing videos of that online when that happened. So that was I had a good chuckle at that, honestly. Because
Yeah,
it's
so
absolutely not something I expected to see when I saw a video of Buzz Aldrin online. That was the last thing I was expecting to see.
well, kind of a military guy, and that's a tough environment, right? And
Mhm.
I think he was genuinely. I've seen the video, and the person was extremely confrontational and unpleasant to him. So it pretty much kind of deserved, I think. Have you ever seen this, Maheen? Have you ever seen this video?
I have never heard of this, and I was laughing quite a bit when you were telling the story. But I guess he should have had his own camera instead of just Neil Armstrong's camera, so that maybe he had more pictures of the moon from his own camera, so it would be more trustworthy for the person. I'm not entirely sure why they didn't believe in the moon landings. But yeah, that's quite interesting to hear.
Well, I will tell you an interesting story about the Neil Armstrong not being photographed thing, and in that the fourth person to walk on the moon was next mission, Apollo 12, was a guy named Alan Bean. And after he retired from NASA, Alan Bean became an artist, and he felt really bad there were no pictures of Neil Armstrong. So he painted a picture called Straightening the Stripes, which is of Neil Armstrong laying out the lunar flag on the surface of the moon in his spacesuit and whatnot. And I actually have a print of this that I got. It's an autographed lithograph, and it's a remarkable picture. And the story behind it is that Alan Beam felt that somebody should have at least captured that moment and didn't. So there it is. But I see we're at halftime now. So what I'm going to do is I'm going to do some reminders. You are listening to the York Universe, York Universe, the Space and Astronomy podcast from York University, and we're broadcasting live from the Allan I. Carswell Observatory at York's Keele campus in Toronto, Ontario, Canada. Please take a look at our website at yorku.ca/science/observatory to join in the chat. If you have any questions, you want to see some of our content. And of course, if you're following our OPV, you'll see right now we've got pictures of a Venus transit and M82 and M63 all up on the screen. And these are great images. And I will point out that M82 is called the Cigar Galaxy. And the Cigar Galaxy is available to you in our calendar this year. Every year, the AICO produces an annual calendar. And for the 2026 calendar, which is available from our website and the York University bookstore for the fantastically great price of $15. So, please, it's a way to get something for donating to the university effectively, because all the proceeds, all the profits go to fund our student-run observatory. And we've got, I think, 14 images in there, all taken by students or friends of the observatory. And they're great. They go from the very near, the moon, to the sun, all the way out to neighboring galaxies. I think the furthest object we've got out there is probably M33, which is a local galaxy. It's on the cover. It's a beautiful picture. So please check that out. Also, we've got our regular observatory tour schedule. So our next tour is on Wednesday, and they continue weekly throughout the winter. And then we switch to a slightly different schedule. It's the same time, but in the spring. And we mix it up with different types of events on Wednesdays there. But you can check out our website. Now, it's free. We don't charge for this at all. But we do ask that you try and get a ticket beforehand. And those tickets are available, again, totally free on our website. So, and while you're on the website, of course, as I mentioned, you can just sort of click on over and in the post a few days later, after you provide your credit card number, you'll get a copy of our calendar. So please give that some thought. Okay, so it's time to go into the news, and we've got a real space focus for our news today, like as opposed to astronomy, it's space science. But Suna, you've got something, a kind of a, a first, not the happiest story, but not terrible either. But why don't you tell us about it?
Yeah, so this is a super rare type of thing to happen with human space travel, and hopefully it stays that way, which is that NASA recently had to do kind of emergency medical evacuation because one of the crew members aboard the International Space Station had some kind of medical emergency. The crew that evacuated in particular this time were all members of the Crew 11 mission. Crew 11 is part of the collaboration between SpaceX and NASA, which provides NASA with the capabilities to send crew to the International Space Station. This is the first time that they were able to do this since the end of the Space Shuttle mission. And in between the period of time between the end of the Space Shuttle mission and the beginning of Crew Dragon programs in 2020, we're relying heavily on Roscosmos and Russia to send astronauts to and from the ISS using the Soyuz capsule. So this has been a really great series of missions through NASA and SpaceX. And thankfully, all of them have gone, pretty well. They haven't had to do any of these medical evacuations. But I believe it was sometime last week, NASA announced that the 4 crew members of Crew Dragon were going to have to return to Earth about 5 weeks early because one of the crew members had a medical incident. They are not elaborating on who it was that had this medical incident or what the incident specifically was, just for the sake of privacy. But it was severe enough that they had to cancel one of the extravehicular activities they had scheduled on January 8th, and then later had them brought home 5 weeks early on the Crew Dragon spacecraft, just so they could provide the crew member that got sick or had the medical emergency with the required treatment. So they ended up splashing down off the coast of California on January 15th. And thankfully, they're all doing well. They spent, I believe it was just the night in California, using kind of like the typical routine for when astronauts return from the ISS. And they are now at the Johnson Space Center in Houston, undergoing the, again, kind of typical amounts of like medical screenings and stuff that all astronauts get once they return to Earth from space. And of course, the astronaut that did have the medical emergency is getting treatment for that. So currently, because the Crew 11 crew had to leave the ISS 5 weeks ahead of schedule, there is no replacement crew on the ISS for them at the moment. And instead, they're basically operating on what NASA has called a skeleton crew that has only 3 people that had launched to the ISS aboard the Soyuz, I believe at the end of November. There is a Crew 12 mission that was set to launch on February 15th, but given the fact that there are so few astronauts aboard the ISS at the moment, NASA is considering bumping the Crew 12 launch date up a little bit so they can get back to the sort of normal 7-member crew on the ISS at any given time. Must be a lot of work with only 3 people on the ISS at the moment. So hopefully they get the Crew 12 members up there soon. But one of the interesting things that I wanted to talk a little bit about with this news item also is just exactly how rare these medical evacuations are. So the fact that NASA was able to do this evacuation so quickly and so well is definitely a testament to how good NASA is at taking care of their astronauts and the people aboard the ISS. Um, but apparently, this was the first time in 25 years that they had to do this sort of expedited evacuation from the ISS for medical reasons. And there's kind of a couple of reasons why it ends up being so rare. First of all, is that NASA and any other space agency who is sending astronauts to space does extensive health screenings before they send astronauts up. So they're not going to send somebody up if they have any type of medical issue that looks like it might cause problems when they're in space. But astronauts do tend to get a lot of minor health issues when they're in space. Some of them are things just like, having trouble sleeping. A lot of astronauts also experience some problems with their eyes, where the fluid in their eyes sort of reacts differently to microgravity than it does under normal gravity, and it can kind of cause issues with their vision. There's a whole bunch of other kind of even smaller kind of health issues like that astronauts do deal with being in a very different environment. So they have a whole pharmacy basically of medication up on the ISS. That can treat a lot of these more minor problems. They also, of course, can communicate with the Earth anytime. So they do have access to NASA doctors and people that can kind of give them some guidance and treatment of ways that they can deal with any health issues they have while they are away in space. So thankfully, this remains very rare of an issue, and hopefully, again, it stays that way. We don't want to hear of any more medical evacuations. But I'm hoping that whichever astronaut was sick and had the medical emergency is doing well, and hopefully they're going to be feeling better soon.
And
Yeah,
this
it's
is very
interesting. Sorry, go ahead, Naeem.
Yeah, I was just saying it's very sad to hear that this happened, although I'm glad that they made it back safely. And it also reminds us of the fact that with manned missions, there's always going to be certain limitations that cannot always be predicted, such as this case of a medical emergency. And despite the frustrations that we often feel with space missions being delayed, there's always these kinds of concerns behind the delays that are happening, especially when it comes to manned missions, because they have to take into account many of these things that come with sending humans into space.
hmm One of the other things I remember reading about was there was an astronaut who, when he was on a space mission, his sister-in-law was severely injured in an accident, and they couldn't bring him home sooner for that. So I remember reading a kind of interview that astronaut had done about how difficult it was, kind of being on the ISS and having this like major family emergency and being kind of stuck up there essentially. So not only just with problems with the astronauts themselves, but it can be a very scary thing to be up there and have all your family and people you care about so far away from you where you can't reach them.
Yes, definitely.
Yeah, it's a bit tricky. There's a lot you can learn about this from Antarctic uh, exploration. There was a case a couple of decades ago where I think it was in the U.S. base where there was a physician on staff there, but the physician herself, uh, they found cancer in her while she was there. Middle of winter, they couldn't fly her out, so she had to actually perform surgery on herself with assistance. And but Chris Hadfield spoke about this. All of the astronauts are trained in surgical procedures. In an emergency, they can do basic operations. Obviously they've got good first aid skills. But you start to ask the question, as we go further away. I mean, the ISS is only a couple of 100 kilometers up, call it 400, I guess. But when you've got a moon base, suddenly you're 3 days or 4 days away from Earth. If you're in Mars, you have to have basically a hospital there,
hmm
uh, at least the ability to do almost anything because first of all, there's some times of the year you just can't get home. And
hmm
there's other, like as with Antarctica. And there's other times where even if you can get home, it's going to take 4 or 5 months. So this, space science, space medical science is this is there's a lot to be learned from the Antarctic groups as well, but
Yeah.
it's relatively new.
Yeah, there are also, I'm not sure if there's any at the moment, but there are quite a few astronauts who are actually medical doctors. So in some cases, you do have medical doctors who are aboard the ISS. And I guess especially for the longer term missions like to Mars that you're mentioning, it would be very important to have somebody like that on the crew, who could actually kind of help intervene if there were any medical emergencies on board.
Yeah. But I mean, speaking of missions like missions to Mars and stuff, there is a bit of news out of the U.S. government. NASA, NOAA, which is the Oceanic Weather Group, basically, and NSF funding was recently restored by Congress. It's a bit of a rebuff of the Trump administration's proposal, which was to drastically cut funding for science agents or federal science agencies. And this was a big deal. Like they were looking at cutting NASA science budget uh, more than in half. It would have eliminated a number of missions that were already underway and cleaned the board across the board for new science missions. Uh, but Congress basically didn't want to go ahead with this. So if they had, it would have slashed the NSF's budget, which is the group that funded Gemini and Vera Rubin and a whole bunch of others, by more than half, by 57%. The science budget would have been cut by 47%, and NOAA's budget would have been slashed. NOAA would have just been, decimated. So it faced a 27% cut, but that's a big chunk. It's a much smaller agency. So that bill, they basically it the new budget does reduce overall spending, but it was quite bipartisan, suggesting that members of Congress chose to preserve the status quo or maybe some slight cuts. The package even includes boosts for a few science programs singled out by elimination by the Trump administration budget request, such as NOAA's satellite program. It also provides a boost of funding for the National Weather Service staffing, which the administration had already cut. There was a lot of NASA missions which were saved. Including the Venus probe Da Vinci and Veritas, New Horizons, which is in the outer solar system, and we've got a spacecraft out there. You want to keep getting data from it. Juno, which has been a hugely successful Jupiter mission. The NEO Surveyor mission for looking for potentially Earth impacting asteroids. And it also made sure that there was sufficient funding for Artemis. In fact, the lunar program got a boost. And the Dragonfly Saturn moon mission. It's also protecting major science initiatives and continuing support for the ISS because, again, the administration wanted to cut its funding for the ISS. On top of this, as I said, there was also extra funding for the Artemis missions to the moon, which we'll talk about in a couple of minutes. But this was kind of like a big, ooh, saved, moment when I heard about it this week.
Yeah, I'm definitely glad to hear that the budget didn't get cut as much as it did. I remember hearing about this, oh man, that was probably like 6 months ago or over 6 months ago when the initial budget was released and thinking, oh no, this is not looking very good. There's already been so much funding that has been cut to, astronomy and science in the United States. So this would have been really, really disastrous.
Yeah, yeah. And I don't know if there was an ideology behind it. It very much seemed to be anti-science because NASA's budget in other areas wasn't cut. It was the science funding it was cut, and the NSF's, which is only mission is science, was cut. So I think there was a bit of an anti-science tinge to this, but whew, saved.
Yeah.
But we do have sort of an item partly related to this that Maheen's going to talk about. So Maheen, maybe tell us about what happened just this week. In fact, yesterday, I think.
Sure. So for my news item today, I have some news related to the upcoming Artemis 2 launch. So as some who are listening may know, Artemis 2, the first crewed mission to return to our moon since Apollo 11, is scheduled to launch in only a few weeks. Before the launch actually happens, the rocket needs to be moved from the vehicle assembly building at the NASA's Kennedy Space Center to its designated launch pad at Cape Canaveral. And the good news is that the rollout to the launch pad is now happening, which shifts the focus from rocket assembly to launch campaign, which is quite exciting. This is where the vehicle will be connected to the pad infrastructure, from electrical to propellant systems, and powered up to check for launch readiness. The necessary testing and rehearsals for the launch day now begin. This includes something called the wet dress rehearsals, which are designed to uncover the real-world fueling and timing issues that might show up during testing, in the same way as would be on the launch day. And this is one of the reasons why we don't always know the exact date the launch will happen, although currently they are targeting to launch in early February, with the first potential launch opportunity opening up on February 6th, 2026, which is only in a few weeks. This four-person crewed mission will loop around the moon for 10 days before returning to Earth, so they're not landing on moon, but it is a test flight to determine astronaut safety in deep space by the designated spacecraft, which is called Orion, and other support systems. So I guess it's like a huge step towards further manned space exploration missions so that we can be sure in the future how ready our spacecrafts are, or NASA spacecrafts are, to send these manned missions to the moon.
Yeah, it's last week we talked about news items that we were looking forward to in 2026, and this was one of the ones we mentioned. It's the first time humans are returning to the lunar vicinity, cislunar space, since December 1972. And if either of you dare to tell me that you weren't alive at that point, I'll scream. So I hear that all the time. But I remember watching that mission too. But it's a big deal and it's a complicated mission. It's nothing. In many ways, it's very different from the Apollo missions. And this is really the only mission they've got to find where the architecture and the mission profile is fully understood. Other missions are coming down the pipe that they haven't fully laid out how they're going to do it yet. They don't even really have the lander for Artemis 3, which is the first return to the moon mission, laid out, and they want their goal there is simply to get there before the Chinese. So it's a pretty big deal. I'm looking very much forward to watching it launch.
And one of the best parts is that there's going to be a Canadian on board.
Yes.
Which was
Very exciting.
I was very surprised to hear that when they announced it. But this will make Canada the second nation to send a human being to the moon. We might not be walking on the moon, but we will be the second country ever to have sent a human to the moon, which is awesome.
Yeah. Jeremy Hansen from London, Ontario.
So close to home.
Yeah, that
Yeah.
makes me happy that the funding has returned to this mission as well, because it directly affects Canadians in some way.
Yeah.
Yeah, it's nice to see us involved. We've contributed to the International Space Station. We've commanded Chris Hadfield's commanded the International Space Station, uh, and we've got a pretty good astronaut corps. You talked about earlier about physicians, astronaut physicians. Well, one of the very first that I'm aware of was Canadian Roberta Bondar,
Hmm.
who, yeah, she was a physician, and she flew on the space shuttle early in the days of the space shuttle missions. But yeah, this is a big deal, and it's coming up, and it's going to be tight because they're going to do the wet dress rehearsal about 3 days before the launch. And if anything goes wrong, the launch will be scrubbed probably, and it'll move it out by at least a month because you've only got so many windows where the moon's in the right position and the Earth's in the right position and the lighting's exactly right to carry out the mission objectives because a lot of that is observational. So it's going to be a nail biter, but very exciting. Um, I do need to move on to our last sort of item because we're running out of time. Excuse me, somebody caught my throat there. Sorry. Yeah, so uh, one of the missions that got canceled as a result of the budget cuts are the NASA's plans for Mars sample return. So we talked about the Opportunity rover. Well, there's the Perseverance rover, which is traipsing around Mars right now. And one of the things it's doing is it's collecting samples that could contain evidence of alien life. So, when it collects a sample, it collects two of samples of everything, and it drops one on the ground where it collects it, and it keeps the other one in a cache internally. And the idea was to send a mission to go and retrieve those samples, either from the cache internally or from the ground, or a combination of both. Um, that mission has been canceled. Uh, and that's a really big shame, but there is some logic to it in a way. Um, it was a problematic program. Uh, they really didn't have an architecture to do this very well. And every time they tried to develop one, it got more and more expensive. I think it capped out like at $11 billion, like some ridiculous number. Um, and it really wasn't viable. So it's not a big surprise, but it is possible that this mission could be restored in an alternate form in a lower cost manner. And bear in mind, those samples are in a pretty safe place. We know exactly where they are. They're in the rover. The rover's got a couple more years of power left, and it's still doing its mission. It's an extended mission now, so we might be able to get there. They were making some progress because originally the original plan was to send two rovers, one with a rover and a return vehicle, separate missions, and a third mission in orbit. And you would have a rover run around and collect the samples, and it would bring it back and put it in the return spacecraft, which would fire the samples up into lunar or to Mars orbit, and then another spacecraft would basically capture that and return it to Earth and drop it down on Earth. It was just three separate missions, maybe more launches. So it was a really complicated and maybe unnecessarily complicated mission profile. So time will tell. We'll see. I mean, it might come back, but a bit sad. But if you're going to cancel something, the one that has got the least likelihood of coming in on budget is maybe not a bad idea.
I
Yeah,
think it would have been exciting to have had the sample return because we would learn so much more about Mars than we ever have had before. But then at the same time, it seems a bit risky because I don't know like if how predictable it is for the sample to have returned and if it would be a complete waste of money for them to send two different spacecrafts when they've already explored Mars so much. But yeah, that's kind of what I was thinking about.
Yeah, it's yeah, it was a complicated mission architecture. It really was. Um,
Yeah.
well, with that, sorry, go ahead, Suna.
Oh, no, I was just gonna say I was whenever we talk about these kind of complicated missions, I always sort of wonder how much the influence of, the planning and execution of James Webb might have
Yeah,
influenced
Mhm.
a lot of these decisions because it was like billions of dollars over budget, over 10 years delayed. So I know at least for the planning of future space telescope missions, that whole thing has definitely had an influence on it. So I'm wondering if
yeah.
there's a similar thing kind of going on with you need to have a budget and a plan a lot more pinned down before you start sinking money into something.
Yeah, and there are possibly ways to do it a lot easier, less expensively and simpler. But we're at time, so I'm going to thank my colleagues tonight and say to our listeners, well, friends, it's time to close up our podcast for this evening. Thank you for joining us. You've been listening to York Universe, the Astronomy and Astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Suna Withers, Maheen Mahani, and me, Paul Mackin. This podcast and past episodes are available wherever podcasts are distributed. You can always connect with us on Instagram at York U Observatory or on Facebook at Allan I Carswell Obs. Our website is yorku.ca/science/observatory. And there we have a lot of interesting content. And if you're so inclined, it's a great place to make a Canadian tax-deductible donation to our student-operated, not-for-profit observatory. You might even be able to pick up a calendar. Anyway, thanks for tuning in this evening. Oh, we wish you clear skies and a good evening, and everyone, please stay warm. Good night.
Have a good night.
Have a good night.